they can plug in here, right? I can put my laptop away, and then they can plug in here. Yeah, it's okay. I mean, we have a little bit of time, right? Yeah, looks great. Beautiful. Yeah? Oh. So, yeah, it's a bit difficult because I'm talking to them basically. Or like this, like I can stand like this a bit, then you can film me from the side. Yeah, yeah, I don't know. You can see it. I'm tall, so I can also stand like this. Yeah, if it's not vertical, it's better. You're in the screen. No, please stay, please stay, please stay. Yeah, it's fine, whatever. Shall we, it's okay, Jeroen?
Ready for departure?
Okay, we're ready for departure. So almost on time. So really tight schedule tonight. So welcome at the Nanocopter AI Challenge. So what are we gonna do tonight? Oh, let me see if this works. Oh, okay, that goes quickly. So, why are we here tonight? So we have the Nanocopter AI Challenge, and it's all about very small drones. So it's a challenge that is being supported and sponsored by BitCraze, and that make the crazy flies. And you see some of them in here. I must say the black window is hiding some stuff, but why are these small drones nice? I mean, they're very safe. They can fly in narrow spaces. They have little aerodynamic effects on the environment, so I don't know if anybody ever flew like a big quad over their desk, but then all the papers, they blow away. And actually, if you're in greenhouses, then one of the concerns is that if your drone is too big, that the downwash actually damages the crop, for example. So these small drones, it's very nice actually properties they have. So on the left you see a video where we're doing gas leak detection with swarms of these tiny drones. And on the right you see a video in which small drones are actually exploring one of the floors here in the building completely autonomously. And today we want to make a next step, because these drones are still relying on small laser small lasers. But today we want to push the state of the art towards onboard vision, and specifically onboard deep vision for these tiny drones. So, so the goal here is that the teams develop fast vision-based obstacle avoidance in an unknown indoor environment. So you see that here. So this is what we call the Cyberzoo. So the Cyberzoo is our indoor test arena, and we put obstacles there that the teams were not necessarily aware of. And drones will have to fly there and avoid obstacles. Now, here you see one of our own experiments in which we had a crazy fly, and we put a little deep net on board of a GAP8 chip. So there's actually a team here that started the development of this chip. So I think it's pretty cool that they're here. Can you wave at us? And so, yeah, anyway, so it's cool that they're also here for the competition. What we did is we had a little fully convolutional network that takes the images over time and determines optical flow. So you see when it goes down it becomes red, when it goes up it becomes blue, and the other way around. So that's actually also making this sinus motion that we saw in one of the presentations. I know Lucia is here, but it's actually oscillating up and down to generate flow to be able to see the obstacles. Now tonight we will see teams with, of course, different approaches. Some will use the Crazy Fly to stream images off-board and process them off-board, but there are also teams that are really using the GAP 8 kit on-board to do the processing on-board. And this, I think, both is exciting, but I'm really looking forward to that. So a little bit about the rules. So it's always nice to know a little bit the rules when you look at the competition. So it's actually pretty simple. So they have to fly around. They have to avoid obstacles. What we count in the end mostly is the covered distance. So flying fast also has advantages, because if you fly faster, you cover more distance in the finite time that we give them. But you see also these little gates, and they can gain extra points by flying through these gates. So you see them there. It's the little orange square gates in the Cyberzoo. And so if they fly through them, they get extra points. And of course, they get a huge applause by the audience, I think. And that's it. So each team is going to fly twice, and each run is 5 minutes. So what you will see is a team comes here, they present their approach to you, then they have a 5-minute slot for flying, and then the next team comes and they present their approach, 5 minutes flying, and they do this twice. So that's pretty cool. And this is the planning for tonight. So as you can see, we're perfectly on time. Okay, we're 7 minutes behind, but so what I would propose is that the Pulp team, actually if you could come up already, and then I'll unplug my laptop and I'll give you the microphone and you can present your approach. Shall I get the mic? Okay.
Thank you very much for the very kind introduction. So we are pleased to participate in this very first challenge with the Big Crazy Flies. We are the pop team. Actually, we are many more people. Today there are only 3. We are a very heterogeneous group. We come from 3 different institutions. We have University of Bologna, where I come from. They are circled in red, so it's me, Lorenzo, Victor, and Francesco. Then we have TII, the Technology Innovation Institute from Abu Dhabi, with Lorenzo, and then also Michał and Agata. And then we have Itzia from Lugano, Switzerland, with Elia here, but also Gabriele and Daniele. So I would like to give just a very brief overview about our approach and the story behind our approach. So everything begins with an idea, and the idea of the PAL team was like to enable CNN processing on board of very small devices like drones. For doing that, you need a lot of computational power that usually is not available on these kind of platforms. So we, Daniele Palossi, did the very first job on this, the very first work, and he embedded like this 8-core processor on board of these Crazy Flies by developing this additional deck that you can just plug on top of the drone. So after doing this work, Big Craze really liked the project, and fortunately they made a commercially available product out of it. So now we can also buy it, and we don't have to solder it every time. So now everybody can buy the AI deck. It's basically very similar to the first version, but now we also have a Wi-Fi module to like stream images. As a group, we put a lot of effort into how to deploy neural networks on board of these devices. So we have a full stack. I would like just to mention it. If you're interested, you can drop an email. But basically, to deploy a neural network, we need to first quantize the network, because there is no floating point unit aboard of these devices. So we quantize it. Then we have Dory, which is an automatic tool for deploying the C code on board, because you need to translate between Python and C to run on board. And finally, we have also the POP team, the POP group, more in general, developed also the basic kernels for processing CNN. So this is the full stack that we used for our approach. And finally, let me introduce POP DroneNet. So DroneNet was originally a work done by Loquercio in 2018, and basically they were doing obstacle avoidance and lane following on a very big drone with remote computation. We, Daniele first brought these on a nano drone, which is the big craze you're gonna see today. And we did already a lot of work. You can see here a few papers. But basically, yeah, we cannot predict a steering angle for the drone based only on the visual images. So we do all the processing on board, not remote. And we also detect collisions. As last slide, if you're interested in our work, please read about it. These are the papers that we wrote about it until now. And this was everything. If you're interested, we also have the GitHub page here. And thank you. Now we're gonna try to fly.
Okay, good luck. So the first ones, no pressure. This is gonna set the bar. So what I forgot to say is that so every team has the same hardware. So they have the AI deck that was just explained. They also have a flow deck. So with the flow deck, it's looking down, and it has a little camera for optic flow and a little laser for the height. So they know their speed. So there's basically a good state estimation, let's say, from the Crazy Fly. So inside we have some judges. So there's people counting how often the drone flies through a gate. There's also even a judge that may sometimes move an obstacle. So we only move obstacles behind the drone, so in the direction that it's not looking, because else they become really dynamic obstacles. And we didn't choose to do that this year. And to be a little bit kind to the teams. Yeah. Next year. Yeah. We're ready. Does somebody have a clock, or should I do it? Okay. Yeah. Okay. Tell me, Sanyu. 3. No? Can you count down? Oh, you count when they take off. Oh, okay. Oh, yeah. Okay. That's nice. Yeah. So they've started. So the first one's up. So. Okay, it's already avoided the first obstacle, so that's great. And determining a new direction. Of course, I'm now guessing what's happening in its mind. So it's in the border of the arena there. Yeah, and it's trying to make speed from time to time, so we can later ask how they implement implemented that. I don't know if it's standard part of DroneNet. So we found our jamming judge, so that's Federico Paredes Valles today. So the gates are actually, of course, they're nice to fly through, but they're also difficult obstacles because they're quite thin compared to some of the other ones. Yeah, so indeed, it's much more fun if they crash, right? Obstacle avoidance, but they're just not crashing. Why not? So Federico, if you want to be really mean, then you can put the boards like really thin. I think until now this is an amazing run, and because it's purely vision based, all on board. I also don't know how much they needed to refine or retrain their net. I don't know if there's somebody that would have time to answer a question or two, or are you very busy with the operation? Okay, we can do it later. We can do it later. Yeah. So what do you think, Christoph?
I'm not sure if everybody's aware, but this is a very big step towards miniaturization of AI. This team is really running all its code on board. The total system weight, if you compare that to what we saw like 10 years ago at IMAV, we were struggling to hover just a half a kilogram or 1 kilogram platform with PC 104 boards, Pentium computers. But here, we don't just have the stabilization and the autopilot, but on top of that, the computer vision is running on board. I think it's quite cool to see. It's the first year we have such small vehicles really flying completely by themselves. So what do you think?
I think you're right. So I'm now wondering, you know, the flags are also actually quite hard because you have the bottom is pretty thin and they fly actually exactly at that height. And so, but yeah, they seem, I mean, it doesn't seem to be on a collision course with them. And so we, of course, hope we can see them avoid it. And I think it's also nice to see that it's actually, you know, going through the entire arena now and not just being stuck in one part. I think it's a little bit thanks to the influence of the environment by our jamming judge, but it's quite nice.
When most people think about AI, they think about Amazon Web Service clusters with all kinds of GPU cards. The fanciest card is not good enough, so you stack them with multiple computers working in parallel. But here this team managed to squeeze the computer vision into a tiny chip. I just looked up, it's 512 megabit, not even byte, bit of memory, and nevertheless, with some fixed point processing, isn't it? Wait, I'm looking at the developers over here. Let's get some correct figures.
Yeah,
Kimberly.
I'm not exactly sure about the exact figures. I don't know if somebody can Google that very quickly. But let's say the AI deck data sheet says indeed exactly what you're saying, 512 Mbit hyperflash. Yeah, but but it's definitely a lot more capacity, let's say, than the STM32F4 has that I used to do my PhD on, and absolutely did nothing intelligent on there. Well, simplified intelligence. That's what it is. It flew, but this definitely gives a lot more, let's say, computing power on a small platform. So enjoy the competition.
So when they land, the time stops. So I don't know how much time we have left. Oh, it's completely finished. It was the 5 minutes was up. Okay, so congratulations to the team again. Sorry. So did you put something to accelerate DroneNet, and did you need to refine the net in this arena, or it just worked out of the box?
Yeah, no, it was DroneNet, just with a different controller, but basically the same approach.
You didn't need to retrain or refine.
We just use a build simulator. That's it. Yeah, not much. Yeah.
So they really trained in a simulator and then transferred to reality, and it went very well, I think.
It's a simulator to reality transfer. It works very, very well.
Did you do any kind of variation in simulation, like change lighting or things like that, or is just like straight?
No, like there was the data augmentation approaches that you use in deep learning. That was also part of the work that we did.
Okay.
Something that was not specific for this work. It was already in the original DroneNet. I'm not really up to date with the details on that. He knows more about it.
Okay.
Yeah, that was definitely part of it.
Cool. Well, congrats. I think it was a very nice run. Of course, as an audience, you hope for worse runs, right? Where you see like high-speed crashes. And so perhaps the next team, UPIM from Madrid, they can provide us that now. I hope not, of course, for them. Have they already arrived? Yeah, almost. Okay. Oh, okay, they know that, yeah, okay, great. Yeah. So they're stuck upstairs. I cannot see what's happening there, but it must be terrible. So I hope we can welcome them downstairs soon. There's a little baby food like table, and there's also a very Dutch game, Schule. So it's little discs, and you need to slide them through holes. So I guess they're stuck doing that. So, but we don't mind to wait, right? I mean, so yeah. Okay, great. Hi. Hi. Okay, so we have the second team here. You're the presenter?
Yeah.
What's your name?
Pedro. I'm Pedro.
Pedro, pleased to meet you. I'm Guido. So I'm going to give you the mic, and then you can present your approach.
Okay, thank you. Well, we are part of the computer vision and aerial robotics. Computer vision and aerial robotics We're part of the Universidad Politécnica de Madrid and the Center of Automatic and Robotics, part of the university. We are 5 people here. There is also more people left in Madrid. Yeah. So.
So it turns out it's harder to project PowerPoint on the screen than it is to fly an autonomous drone in the arena. So sorry, back to you.
Yeah, as I was saying, we are computer vision aerial robotics, part of the Universidad Politécnica Madrid and the Center of Automatics and Robotics. We have our framework we use to fly drones, not only Crazy Fly, also bigger ones as Matrix 300 and all Pixhawks and other stuff. We are currently developing a second version based on ROS 2, and that's the one we are going to use today. Our strategy today is based on two steps. The first one is a perception. We use a color segmentation for object detection, and then for gate detection or identification, we use a bounding box aspect radio for getting the door, the gate itself. Then for the control, we use a visual-based control, really simple one. We use the bounding box to get the center of the gate, and if the object is an obstacle, then we center the pixel, the center of the image, far away from the obstacle to avoid them. And yeah, that's it. Thank you very much, Guido.
Okay, great. So thank you for the explanation. Okay, so not much. I think not much was showing here. So, but they do detection of the gates, also helped by the color. So I hope they're also going to try and fly through the gates. So I would like to see that, of course. So let's see how they're going to do. So is it fun to stream, Sven?
No.
The answer is no. So we were distributing tasks and Sven was, I want to do the streaming. So the team has all kinds of rituals to prepare the drone for the test. And so I just saw him kissing the drone to wish it good luck. And now he's attaching the battery. Okay, so it seems that we're almost ready to take off. they aligned it with the gate, so of course we're now hoping that they'll fly straight through immediately upon the start of the run. So let's see if that's going to happen. There it goes, there it goes. Does it go through? Oh, almost, almost. So there was a very close attempt to gate pass through. And the judge was very strict. They have to take off from the place where they crashed. It's good, huh? We do not have VAR like in football. Yeah, so there's nobody double checking Federico. Yeah. So there's yeah, he's the ultimate authority on what's happening in the arena. So second attempt. So when the battery is finished, then actually you can pause. But if it crashes, then actually the time continues. So that makes it actually quite challenging. So Jesse, how are you doing tonight? Good? Yeah, so tomorrow, yeah, you've been involved in the greenhouse competition. Yeah, so are you looking forward to it?
Yes, very much. We saw some very promising runs by some teams, and I think they will make a lot of very nice pictures of tomatoes. They will maybe also crush some tomatoes, but yeah, we'll see.
So there will be a little bit of ketchup in the middle of the run.
And for lunch, we also had tomato soup made by the drones.
Okay, nice, nice. And tonight, did you ever see a nanocopter before with AI on board?
Not so nicely as the ones I've seen here.
Cool. And I don't know if the time is running. Is the time running, Sanyu? It stopped. Okay. So the judges have been kind. Is that? So yeah, it seems to be almost more complicated to do the streaming than the actual AI, right, Yilun?
Yes, sometimes it can be the case.
So you prefer to do like deep neural network training than this?
Yes.
Okay. We shouldn't broadcast this because then nobody ever wants to do the streaming again next year. So the drone got up again, and let's see what it will do this time. And there it goes. So I think it detected the obstacle and wants to turn away. But what you can see with the quad is that, of course, to turn, it's actually also still slipping a bit in the turn, but it went all fine. So you see the orange ball next to Federico. It has a very nasty, dirty stain. We don't know what that is. Ooh, in the net. Almost into the operator area. So it was trying to fly through one of the mazes in the net, I think. So I think this was all on purpose. I think this was all planned. So Christoph, it's flying again. So whoa, through the gate, just through the gate. Oh, come on, we give it an applause anyway. It was through the gate. Of course, we hope that there will also be a pass-through where it doesn't afterwards look for the ground, but this was already the first pass-through we see tonight. So, yeah.
Yes, to approach this competition, teams have apparently two main strategies. Let's start with the hard strategy is to compile AI that fits on board. That's much more difficult, but that has the advantage that you have less delay, it's more reliable. Other teams have opted to downlink the images through Wi-Fi. With Wi-Fi, sometimes has a little bit more delay. Then you can run much fancier computer vision on your laptop. But of course, if your data link is lost, that makes things very difficult. And especially delays in Wi-Fi can sometimes build up. So we kindly ask you not to stream too much on Wi-Fi. I just said the opposite a minute ago, so to watch on YouTube. So another attempt. The drone is rebooting. Flash, flash. Go for it, guys. Even though the task is pretty hard, we gave a simulator to the teams, but the simulator is not like reality. For instance, the simulator has the poles, but does not have the moving public. So if your algorithm appears to be sensitive to that moving public, then that's a bit of a problem. The light conditions are always very different in real life than in simulation. So making algorithms that can cope with that is another part of the challenge. I was personally very impressed to see the simulator to real world transfer learning quality of the first team. So this appears like an approach that the teams of a future IMAVs might take into account. Unfortunately, the timer has passed. I've just been informed that the 5 minutes are over. Can we give this team a very big applause for them? Well done. If you can learn something from this run, quickly implement it. You still have a bit of time. You get a second run.
Yeah, so now is debugging time for team UPIM from Madrid. And in the same time, we would like to welcome the Equipe Skyrats to the podium here. So warm applause to the Skyrats. Perhaps they were also blocked upstairs with a little schooling game. Very good, so there they are. So I guess they were testing somewhere close to here their solution, secretly, no? It's not the quickest. Ah, great. Okay. What's your name?
My name is Fernando.
Very nice. So you're gonna present your solution tonight?
Yeah. I hope so.
Are you confident?
Reasonably so. I mean, too much confidence is a little bit not healthy, but we're pretty happy with what we achieved so far. I think we can get a good show.
I'm very curious. So what did you focus on? Flying fast or?
Well, we mostly focused on our gate detection algorithm, as well as having pretty tight control over the drone. We, as we'll explain further in the slides, but yeah, it's running everything on board and trying our best to both dodge the obstacles and get into the gates as fast as possible. Though we're not necessarily focusing on speed, we're trying to grab all we can. If you,
Very cool, very cool. So sounds exciting. Onboard solutions. So I think it's important to mention. I don't know if the streaming is kind of working here. We have some problems getting the HDMI in, apparently. Ah, it seems to be working on the stream there. We can leave out the images else, if... But it's easy, right? Because it's autonomous. So, I mean, you click on something and then...
yeah, then obviously you just press the button and everything goes. You don't even need to think about it.
You just watch it shine, right? So,
I mean, it's autonomous. That means it basically does it for itself, right?
exactly. Okay. I think it's fine now. So I'm gonna give you the mic first.
Okay. Hi everyone. We are members of Skyrats, a autonomous drone development team made in the University of São Paulo in the Polytechnic School. We're all undergrad students, so bachelor students, and we're here to present our solution. We're both the members of the particular a Nanocopter AI challenge team, and we're going to present our solution. Yeah. Next. Our general strategy involves mostly autonomous exploration and the search for gates. So we worked fully on board, so both a obstacle detection AI as well as a gate finding algorithm are running on board on the AA deck. And our strategy is going to be to navigate the whole arena, trying to dodge the obstacles as well as we can, those obstacles being dynamic, hopefully, and getting through the gates when it finds it.
Yeah, so our general strategy consists of two parts. So first, as my friend said, is the obstacle avoidance, which you have already seen part of it, because it was made. We are also using the drone net, which was made by Lorenzo and people at Poop. Sorry. So props to them for that, and thanks. And the second part is the gate detection, which, as we said, everything is on board, and because we had to write everything from scratch. So, yeah, we had to write most standard image processing algorithms from scratch in C to run it on board alongside the obstacle avoidance AI. So as you can see, that's an example of a picture that we took yesterday of our gate. And yeah.
Finally, after having taken a look at both the Pulp.net AI and the gate finding functions, we're going to use those results and make it so it navigates. So at first it's going to take off and search for the gate. If it finds one, great, it's going to try to fly towards it and through it, of course. It will take into account the results of the AI to calculate the average the velocity it should be going at, as well as the rotation, so it avoids the obstacles. And yeah, it's a fairly simple solution, however, but we found that if it works quite nicely, I think. And of course, all credit goes to from Pulp.net. Oh, by Pulp.net, all credit goes to the Pulp team. So thank you again. Without your help, it wouldn't have been possible, even if you didn't know you were helping us. Yeah, having read all of the papers and learning everything, it was a great experience overall. We learned a lot from this. So yeah, we'd like to thank you all for the opportunity and start the thing. I think there's no.
There's who do I give it to?
Well, let's have a look at this. The team is setting up their laptop. This is going to be special. If I understood correctly, they have onboard processing, so no Wi-Fi. So thanks to the debugging help from Pulp. And they will attempt dynamic obstacles for maximum score. Let's see how this turns out. The drone is entering the flight arena. They will position the drone tactically, hoping to get a first extra set of points by passing through the gate, maybe. Now all the hard work is done. The drone is booted. Still, one more action to do is press the start button. When the jury is ready, I see a thumbs up. Now the very hard work for pressing the start. Cameras are rolling. Oh, it's still flashing. It's flashing over the air. I think that isn't that a new feature, BitCraze? Can you comment on that?
Yeah, indeed, that is indeed a new feature. I think it was 2 releases ago in May or something like that that we officially implemented. So that means that you don't have to use that pesky programmer to constantly flash it by JTAG. But yeah.
And we have a takeoff. Look at this. The flashing over the air, the new code has just been uploaded a second ago, and there it goes. With freshly new code. Oh no, the flag. Well done. Just stopping in centimeters away from the flag, finding a new safe direction to fly. This looks good, or maybe a bit lower. Let's go to the gate because that looks very attractive. Passing next to the gate at a safe pace. Don't take any risk. That's a good strategy. It's better to keep flying because you lose a lot of time. It appears to have been not liking the pole. Look at the gate, look at the gate. Oh, oh, whoa! That's worth a very big applause. I think the Brazil. Some Brazilian commentators that want to add some emotion to the. Well, that was very impressive. It made it through the gate. There's still a little update that could be done because the laser ranger appeared to have detected the lower bar and then it climbed aggressively. Just made it through without hitting the top. So if you still have some programming time in between the runs, you know what to do. Yeah, and then flash it over the air. What? The step detector. So are we rebooting? Oh, unfortunately, the algorithm seems to have a particular booting order, a booting sequence, which we will now execute. I hope that does not involve flashing over the air a second time, because it's very nice for the development phase, but maybe it's less optimal during a competition. It is kind of nice, by the way, to be able to develop and have your drone sitting in the zoo, flash new code. If it doesn't work, debug and then reflash without even picking up your drone. That makes the life of a researcher much easier. Instead of you plugging in JTAGs and soldering conversion cables from 10-pin JTAG to 4-pin. There it goes again. Oh, it's trying to go through the gate. It will first go past the gate. It's definitely braking for the shower curtain pole, as we call it. That's one of the easier ones in the sense that it has a lot of texture. Most algorithms like texture. Oh no, that's very, very close. But it just didn't make it. That's such a pity. That's just a pity. It got a bit of a yaw error while hitting the pole, and yaw is very hard to correct on these brushed motor bitcraze copters. But I heard there's a new version coming up with brushless motors, which is much more efficient in yaw. So we'll have to figure that out for the next event. Maybe we can then do some aerobatic competition as well. Oh, unfortunately, the booting sequence is a bit tedious. In the meantime, we see our judge moving the gates because they are running the competition with dynamic obstacles. So it's not worth remembering where they were. Can somebody update me on the time? 1 minute left and 3 seconds. Come on guys, upload. Upload. Maybe I overstated the simplicity of starting the drone, because it looks like a lot of work. I see terminals scrolling by and make, compiling, uploading. 30 seconds. I hope it can still make a little hop. That would give some points. There's a little problem. Oh, that's a battery. And with only a few seconds left, that's not gonna work out. But don't worry guys, you still have another run. So well done so far, very impressive. Give them a big hand. Well done, Brazil. I want to capture that. Go ahead.
Vai Brasil!
There we go. I hope everybody could hear that. In the meantime, if I see Jesse, did he find the next competitor? Team RSA. Team RSA. Romeo Sierra Alpha. And the black drones. Team RSA, please ask. Oh, I see Team RSA. Great, well done. Good to see you. And you have a presenter's laptop location over here. You can still grab a snack before you present. Well. Well, the next team is ready to show their approach to the competition problem. So I'll hand over the mic to Team RSA. Thank you.
Hi, so my name is Tristan, and I'm here today with Luis representing the Delft Robotic Students Association. So for us, the origin is a bit more interesting than our strategy. Sorry? Okay, yeah. Our team fully consists of bachelor students at the time that have close to no experience programming drones. We learned about the competition in May and decided to set it as our goal. But we only really started programming the crazy flight itself like a month ago. Our intended strategy was to skip the big neural networks and just do something simple with the camera with colors and kind of similar to what the other teams do to target the gate. So yeah, essentially using color data to find the gates and avoid the pillars, which we won't be using today. Unfortunately, over the days of testing, we could not get the command loop working as intended, but we'll give it at least 1 or 2 tries and give you a nice, exciting crash to boot. So a big thank you to the team, which are Luis, Rahim, Leonard, Gleb, and Maxime, which are on screen also. And a huge thank you to the IMAV team for hosting the competition. Thank you.
Great. While the team is setting up, this is, yeah, it's nice to see that young people are motivated to try and tackle these challenges, even if they're pretty tough. So hope we can see some nice attempts. But this is a bit of the IMAV spirit. So we want to be at the forefront by presenting very tough challenges. For instance, tomorrow in the greenhouse, flying in a real environment is definitely still a challenge, so that even the best have difficulties with it. But at the same time, still be open to people to learn how to get into robotics by making some parts of the challenge accessible to everyone. So it's really great to see student teams participate. I see a thumbs up. That's a good sign. So that means we can see some action. Cameras are rolling. 1 second. So this team has a little bit less obstacles. That reduces the points, but that hopefully also makes it possible to fly a bit longer. This is all accounted for in the scoring. We have a takeoff. Well done. We have a first takeoff nicely in front of the gate. And it's moving slowly towards the gate, is trying to align, and it doesn't hit it. Well done. So we are still moving. Just a reminder, this is a student team who's only started programming their first drones like months ago, and I'm afraid this is a little bit too close to the edge. When you have a processor like the little gap processor in here, you can also choose to use more traditional approaches, and sometimes that even can help you have faster frame rates. In the context of racing, it's not always everything is won by deep nets. If you're very power limited, using very efficient algorithms can also give you a head start. And a second takeoff, but there might be a little propeller problem. Check your propellers. They're still all mounted. Then maybe you can fetch some information on the Kalman filter, which is currently implemented. Is it? So how well can it cope with tumbling over and then realigning?
Semi-well. It's a bit shaky sometimes.
So we will definitely be testing that feature today, and the recovery after tumbling. which is a difficult thing for the common filters. It can take a while. If the drone has been spinning faster than the gyros can measure, that obviously gets integration error. And some filters afterwards, when they compensate, then also wrongly update gyro biases. So sometimes the best solution is still the reboot. Unfortunately, the black panel appeared to be... oh, thank you. Thank you, Fake. This is definitely appreciated. We'll try another reboot. In the meantime, the Black Bee drones, make sure you're close by and... yep, perfect. We have 2 minutes left in the run. I see a command being sent over the terminal to the little drone. It's sending back error messages. That's too bad. Sending back error messages. I'm afraid the team is calling it a day. There's yeah, a lot of developments. Still give them a very big hand. It was very nice that you tried and that you, I hope you also learn a lot from this and it will help. And don't worry about the results. It's the journey that matters. And thank you for your participation. And maybe you can still try something for the second run. Well, thank you. And while people grab the Dutch tradition called bitterballen, be careful, they're hot inside. Oh, there's cheese balls. the no meat bitterballen. I can call the team Black Bee. Vai Brasil! Yeah. Oh yeah. Thank you. Team Black Bee is going for static obstacles. So we won't move them, but they want all obstacles. So that's already quite a multiplier in the game, in the grading. Setting up their laptop. I like the Brazilian enthusiasm. Keep going. You want the microphone? Cheer up the team.
I don't need one.
All right, are you ready? Here's the microphone.
It's all right. Hello, my name is Rodrigo. I am the software captain of Black Bee Drones, a team from the Federal University of Itajubá, and we are here for the Nanocopter Challenge. So let's explain a little bit of our project that unfortunately didn't go as we planned. The delivery ship of our drones just finished 1 week before we came here. So we had the drone for only 1 week for testing, coding and everything. We had the virtual machine and all the other things, but that's not the same thing that having the drone. But in the beginning, we started doing the gate detection and everything, but it didn't test it. We didn't have the drone for that. So we built the codes in C and everything using the AIs, and we did whatever we could. Well, these are some of the themes of the detection that we took with the drones when we had hit. Then we put it in a paint, selected just the gray area. We are detecting in gray because of the limited processor of the drone. So maybe it would be faster, or that's was what, what we had. Only 1 week, not as many possibles as we could, but let's find. Like I said, it didn't go as planned, and our plan right now is just to fly drone around with not as many detections as we had. So I don't know what's going on. So let's find out.
Thank you. Maximizing the points. So the team is selecting a strategic takeoff location with a lot of free space in front. That's exactly what I would do too. To start off with a good first run before you end up hitting obstacles. I guess that's part of the strategy of maximizing the points. When they're ready, they can take off. The jury is ready for departure. Loading. Loading, still loading. It's good that we have the blinking LEDs. At least we have the feeling something's going on. Now it blinks differently. Can somebody help me? And what does the blue blinking means? Oh, there's faster flashing of the green LED already. That's a good sign. Is this another over-the-air update being sent? Maybe, that sounds very reassuring. Oh, we even have red LEDs for... oh no, it flipped over for some reason. Why did it flip over? It jumped upside down. It's probably... is the backward flip an accelerometer calibration procedure?
I think there are two things that might have happened. So either the propellers are wrong, happened to me too many times that I care to admit, or this grass can be a bit static and IMU is a bit scrambled up. So if you put it on something that's not the grass, that can, yeah.
Yeah, that's a good tip for all the teams. The grass, the fake grass in our Cyberzoo sometimes sticks to the legs of the bit craze, but we have a special cardboard in the corner. So the teams that's flying, if you want to have a safer takeoff, you can put your drone on the cardboard with a big H on it for a helicopter. Quickly check that the clockwise spinning propellers are on the left diagonal and the counterclockwise on the other diagonal. They're checking the drone for we added some reflective tape so that our jury can measure the traveled distance. Does the tape affect anything? I do see a propeller swap. It happens to the best, I was told. So when's the next generation quadcopters where it doesn't matter anymore which propeller you put where? When is it coming? You just let go of the heading control and just. And then you have a scanning camera that looks 360. Another attempt from a helicopter takeoff pod this time. I don't know if you can see it on the video, but we have now, we are not taking any risks anymore. Taking off from the cardboard so that the legs don't get stuck in the grass. That's a good tip for any future team as well. I think this team needs a bit of encouragement. I will see if I can find some Brazilian enthusiasts here. Can you?
Woo! Vai Brasil!
Come on, guys. Push that code into that little drone. I found a team member. Maybe he can comment on what you think is going on.
Oh, vai Brasil!
That was not exactly what I had in mind as an answer, but it will do for now. I don't dare to disturb the rest of the team who's busy with discussing programming. And unfortunately, the timer didn't start yet. Unfortunately, there are some technical difficulties, and the team will try again in a few minutes, but we will switch to the next team. So can we give him an applause anyway for the beautiful backflip? And you still have a few minutes to figure out what happened, and I hope to see you with an even nicer, not just a backflip, but maybe something more, something else.
Come back.
Go for it. So we are calling now Team EMC Plus. Team EMC Plus. Team EMC Plus. Also. So this was a team who was not very clear on whether or not they would participate, but we'll try anyway. Maybe if we all call them at the same time, EMC Plus, EMC Plus. That did not work out so well. So I hope. So I hope we can now call Team Kios, UCY. I was told you had a bit of a hard time preparing for this, but that you have prepared a presentation, a simulation of what you intended to show. We can plug in your laptop, and once the stream is correct and working, then we'd love to know what you have prepared and what the difficulties are. Well, we have some idea about all the difficulties that can occur. Okay, for the next team, we have a simulation, and which is being started. We are loading the world. Programming these tiny processors is getting easier and easier, but it's still new technology and quite hard. The tutorials are improving every month almost. When you compare what it used to be like a year ago compared to now, now we have this over-the-air flashing. This beautiful 4.4 gram, if I'm not mistaken, isn't it? 4.4 gram computer vision board. All right, we have the simulation on the main screen. Are you ready to tell us a bit what you developed and what was the hard part? Because that we of course like to know.
So, okay, my name is Adil Farouk. I'm representing my team from University of Cyprus, Chaos Institute for Research Center for Excellence. The issue that I think we were facing is about arriving here yesterday, and I was a bit sick, so I couldn't properly transfer our solution that you are seeing in the simulation on the drone. Which was due to the lack of time as well for this competition. But what I will show you here is our strategy. We wanted to go for the neural network, but again, it was partially working, so we then thought it's better to stick to the simple solution. Then we made a state machine approach that captures the image as you are seeing here in binary, which is actually the subtraction of this green floor. So it takes out the green floor from the whole environment as white and keeps the other as black. So, and then it calculates the centroid of the green floor, and it tries to navigate throughout the arena, finding these centroids. So you will see it will always stay inside the arena. And the other thing is about the obstacle avoidance. So when the obstacle it sees is close by, so it realizes there is no green floor, so it does a reverse direction flyback and steers to the angle where the green floor is visible. So this was a simple strategy that we followed, and I hope I will be able to transfer our solution on the Crazy Fly and proceed with the drone in future. So for now, this is what I was able to achieve and be here for the competition. So that's all from my side.
Thank you. So, well, it's really unfortunately that we cannot see your drone flying for real, but at least we have seen all your developments in simulation now, and it looked like a promising approach.
Near future, how our solution is developing, and maybe becomes my part of research, which I think is possible.
So this is you're planning to continue to work on this as part of your research. That's great to hear, and we'll keep track of then maybe next year or see if it has any publication. But be careful, because next year the ground might not be green. So all right, can we give? Can I ask a nice hand for this the team? Thank you for all your developments, and it's a pity we can't see it fly, but thanks for showing us anyway. So, last team, not the last demo, because we are every team gets a second chance, but we have the team Crazy File Folder. You'll have to explain where the name comes from. But please first start with plugging in your laptop if you want. Crazy file folder. It's so we're setting up the last presentation. After this, we'll have a demo and a talk by BitCraze and by Flapper Drones. And after those, all the teams that want can try a second 5-minute run, but then we will not have the presentation in the middle, so it will be a bit faster. It looks like all the slides are up, so I'll give the floor to you.
Thank you. So firstly, let me explain why we use this team name. So firstly, Crazy File looks kind of similar to Crazy Fly. And secondly, the file folders in your computer, sometimes it just went crazy. It went somewhere you don't even know. You have to find it. So that's why we call it. So anyway, I'm Chen Liu, and my teammate, whose name is Ying Fu Xu. We are two students from TU Delft. And we provide this, what we called obstacle avoidance by monocular depth prediction and for risk-aware control. So basically, for this task, we use this solution with the help of the wayboat that's provided by the organizer to all the participants. We train a 10-layer depth neural network that will take a single gray image and then output the depth of what it's seeing in the surroundings. And based on this depth map, we use what we say a risk-aware control to control the steering angle and also the speed of the drone. And most importantly, we run this method off board because the neural network is kind of heavy to run it on board. But in the future, we also plan to transfer it to onboard version. So at each time step, the AI deck will take an image and transfer it through Wi-Fi to a laptop, and we run the neural network and the control strategy completely on laptop, kind of in focusing of 5 Hertz. And then output the steering and the speed control to the drone. Here are some image prediction samples, both from simulation and also from the reality. Note that the neural network is completely trained through simulation. So you can see from the left figure of it, all the predictions seems working pretty good. But when we transfer it to real images, we do this by yesterday. For the practicing chance, you can see some cases it fails. And in the right corner of this figure, there is actually a blackboard in it, but the neural network thinks there's nothing. So there's still a problem of transferring. Sorry. Yeah, so for the control part, we take the weighted average of each depth map, and using this depth map to generate risk-aware control strategy. So in the first figure, you can see the depth is relatively far away from it, so it chooses to go forward at high speed. And when it sees obstacles, based on the position of the obstacle and also the distance, it will choose to turn right or left with a given speed. So that's basically what's our method. And let's see how it works.
All right, thank you. Well, another team who trained everything from simulation and tries to transfer it directly from the simulator to the real world. This is definitely a trend that we see more and more in robotics, and with updates in better simulations, it has a lot of potential. There's some problems still to be solved, like the black panel that we just discussed. Timing is very often an issue when you go very quickly. The simulator timing and the real world drone timings are off. The flight dynamics have a bit more fiddly, unpredictable behavior in the real life than in the simulation. But it's great to see the potential, because obviously if you can create a simulator and just have an AI system learn how to behave in there, it's much faster. You can iterate thousands of times per day. This is probably going to accelerate the developments in robotics a lot if we survive the simulation to real world transfer. So let's have a look how it behaves. Which other differences are there between the simulation and the real world? The judges are ready? No, not yet. Oh, we have to reboot OptiTrax. That's sometimes motion tracking systems find the days very long. It's working now. I would want to use this time to quickly thank all our PhDs and staff members and postdocs that have been helping out and that jump in to play different roles. At one moment they're behind the desk, then they're carrying stuff from one location to the next, then they're being the jury. Some are even helping teams to debug their code or even to build new drones. So a big thanks to everyone for your flexibility and your help. Okay, the team positioned the drone in the far corner, giving it a very long diagonal to start. Yes, I will. And we have a takeoff, and the timer has started. A takeoff and an aggressive turn, but unfortunately it was a few centimeters too close to the edge. Remember that this team is streaming the images to the offboard computer. It's going through Wi-Fi again. Be careful if you stream images. Sometimes there's a bit of a delay. When the camera sees that you have to avoid the obstacle, and if you identify that through Wi-Fi, probably you're a bit closer to the obstacle than you actually think in the meantime. The solution, of course, is to reduce the flight speed a little bit to match the delay, or to use fancy predictive control to compensate for delays. But especially Wi-Fi has the funny property to have variable delay, and that makes it very interesting. They are almost ready to have another go. I see people looking at screens very anxiously. Takeoff, nice smooth turns, trying to find a safe area to make a lot of distance. And the landing, why are we landing? We need, there was a beautiful autonomous landing. Is it a battery problem? Is it the edge of the zoo? Take off again. Searching for a safe direction to travel. When it's found a safe direction, you can see it accelerate. It's passing pretty close to our shower curtain pole. Now it's uncertain. There's too many obstacles close by. Where should we go? Let's go in the corner. No, that's a dangerous corner because we have a flag. The foot of the flag is higher than the ground, so you see the drone jump up a bit. But I think this qualifies as a pretty successful run. We covered quite a few meters. If I look at the OptiTrack log, there's a long line that's going to help in the scoring. Another takeoff. No, not the pole. Stop, 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 stop. Followed by a beautiful inverted landing. So the reboot of the system, because we don't have Linux on it, but microcontrollers, you just push the button, turn off the power, and reboot it instantly. It looks like we have some physical damage. Battery change. I mean, we have 2 minutes and 40 seconds. Oh, you pause the timer. Battery changes have a pause function, so you can change your batteries without penalty, except the penalty of taking off and landing. The team is repairing the drone, making sure the AI deck is snugly fit on the 2x10 pin connector. Thanks to our mobile cameraman to give us some close-up images. Oh, there's some replugging needs to be done. Do it carefully, unplug the boards nicely vertically, otherwise you damage connectors. And another battery. We have a boot, 4 propeller spin. The competition effect, everyone who participated probably knows it, but it works when it works in the lab. That doesn't always mean it works in a stressy environment at the competition as well. Things are always more difficult then. Another attempt. Back to the diagonal. Smart move, long direction. And a takeoff. The funny thing with robotics is that while the robot is struggling to boot and initialize its sensors, the only thing the developers can do is to watch it. I can hear some comments from BitCraze who are trying to identify the problem remotely by analyzing the behavior of the robot. And it looked like underpowered propeller due to low battery behavior.
Yeah, so red LED means land. Be nice to your LiPo battery, please.
Just a gentle reminder to always be gentle to your LiPo batteries. Make sure you do not undercharge them. They will start to puff. And certainly do not overcharge them. But last but not least, keep them in storage mode. Otherwise, after a few weeks, even if they were good, they become bad anyway. So another battery swap. Final battery swap for our last team. Okay, the team has 2 minutes and 20 seconds left. That's battery number 3. Let's hope this one is still fit to fly. Normally pilots need to be fit to fly, but here it's batteries need to be fit to fly. The developers are anxiously looking at the laptop screens, hoping that the robot would do something useful. Ooh, we have a pole encounter. This team is trying to fly pretty fast, but the result is that, yeah, the obstacles, the obstacles approach the drone pretty fast as well. Reduce the speed, guys. Can you reprogram with a bit more gentle forward speed? Another attempt. I did see a nice turn for the black panel, which is exactly the panel that they were having trouble with. Don't go backward. And another landing with red flashing LED. Red flashing LED. Oh, sorry, that's the good red, sorry. It's not the empty battery red. Avoiding the window and going just along the pole. And it survived, but it's trying to attack the public. Be careful over there. They fit through the maze. "45 seconds left. 45 seconds. 20 meters should be possible. Yeah, they are going for it. And a clear turn for the orange pole. Searching for a safe direction. No, yes, no, yes, no, yes. Oh, no, no, no. Oh, oh. How many seconds left? A final attempt. We have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And applause for our last contender, Team Crazy File Folder. Next up, we have BitCraze. But what? So next up we have a presentation and demo by BitCraze. We want to thank all our sponsors, and BitCraze has been particularly helpful in this challenge, even offering teams a discount code. So can I hand you the microphone?
Hi, thank you. It's the same as Okay. Hi everyone. First, I want to. I'm Barbara from BitCraze. I want to thank every one of you for being here, and especially IMAV for inviting us and to be a sponsor for this exciting Nanocopter challenge. By now, you already have seen the Crazy Fly flying quite a lot. So I try to make it quick because it's always better to show than to tell. So I want to talk a little about our company and the ecosystem it provides. So, BitCraze, we are a company that's developing the Crazyfly, so the small quadcopter that you've seen, and all the ecosystem around it, so hardware, firmware, software. We are located in Sweden, Malmö, just across Copenhagen, the south of Sweden, and we are actually 6 team members, so it's a quite small company. We're doing a lot of different things. We're actually looking for new teammates, so if you want to check out, if you want to join us, I put the link here. Anyway, and so we are, how BitCraze started is, so Marcus, Tobias, and Arno wanted to see if they could make a PCB fly, and they managed to do it. And they shot a short video of it flying, and it sparked a lot of interest from hobbyists and everything, and so they created the Crazyfly 1.0 and the company to sell it. And that's been 11 years ago. We celebrated 10 years last year, and now we are at the Crazyfly 2.1, doing a lot of improvements along the way. And creating a whole ecosystem. So that's what I want to talk to you about today. So there's a huge ecosystem that we've built around the Crazyfly that's really flexible, that now accommodates for different platforms with a huge system of expansion decks, and everything is open source. Basically, what we want to do is provide a flexible and modular tool so that you can do as much as you can for your research with as few limitations as possible. We want that it's your imagination that sets the limits and not the hardware or the firmware or the software. And how do we do it? Well, first with the Crazyfly that you've seen. I don't know if I can, what more I can tell you. It weighs 24 grams. It has an autonomy of approximately 7 minutes, depending on how much you put on. But we also have the bolt. So that's basically the control board of the Crazyfly, a little bit bigger and with other arms. So you can build a drone around it, pretty much as you want. It fits to the Crazyfly ecosystem because you have the expansion decks that you can put on, and it's you can do anything you want. The flapper drones that we're going to show, the Mate is going to show after, is based on a custom-made bolt. And then with those platforms, we have a lot of different expansion decks that you can put over or under the control board, that allows you for a lot of different things, like having lights, having sound, positioning system, charger, and positioning. Yeah, I said positioning already, sorry. And the AI deck that you've seen flying this evening. And we have, so positioning is a huge important thing for drones. And we have 4 different systems. We have the motion capture systems, so you have markers on the drone that motion capture camera detects. It's a really precise system that can cover large area. It's unfortunately a little bit on the expensive side if you want to buy the cameras. You have the local positioning system, so that uses ultra wide band using anchors and to position the drone. You have the lighthouse system based on the virtual reality Steam provided by Steam base stations, so the infrared lights sweeping around, and that the deck on the Crazyfly catches to learn the position. And we have a 4th, more soft positioning system. It's the flow deck. It's a sensor that detects the floor above, under the Crazyfly to see, detects its position, relative position. and everything is open source. And I mean everything. The hardware partly, the software, the firmware. That's a choice that we made because we like transparency, sharing with others, dealing with others. It's flexible too. We have no locking effects. You can develop everything you want on your machine, the freedom to be able to do what you want with your code. And a big part of open source is actually contributions. So we're really striving for a win-win situation where you provide code and we provide software or firmware or hardware. So we can share a lot of our work together to improve. Basically, that's why I put the greater good as the last, because I think that the more we share knowledge and improvements, well, I mean the best we can be. So you help improving, and you also have more visibility. If you provide code, you have more advantages, more chances to get citations. And contributing is actually really easy. It's something you can do easily in GitHub. Even small things as posting an issue saying, I don't know what this doesn't work, so that the next person that has the same problem actually can learn from it. You can also have custom-made features. You want something specific for your research that maybe we can implement together. Or pull requests, and even sharing your work, the algorithm you've put for the Nanocopter challenges, for example. That's, I mean, just a great way of showing how to do things. A great example of contribution is the Crazy Swarm. So that's a tool for large swarm implemented by Wolfgang Honig and James Price. And you can see on the video it's 49 crazy flies flying together. With the mocap system, and it's now really usually used in swarm cases with a ROS node and everything. And speaking of examples, actually I don't know if you've noticed, but my colleague Christopher has been working since I've been beginning talking, and he set up a lighthouse system that I think you can show. Question mark? It might work. So, So that's the lighthouse system. As you see, it's really you put it together in what 10 minutes, a little under 10 minutes. Seven. Just putting with the 2 base station and calibrating and the crazy fly flying, really precise and stable. Thank you, Christopher. And that's it. Thank you again for listening. Thank you for having us, and have a great end of the challenge.
Thank you very much. I think it's really great. Also, the open source philosophy, I think it's fantastic. So thank you very much for supporting it, also from the teams. Very nice. We have still a presentation for you by one of our sponsors. It's Flapper Drones, and we have tonight with us Maciej Karasek, representing Flapper Drones here tonight. So I'm gonna give you the floor. Are you first gonna fly?
Thanks, Guido. No, I'm not going to fly first. I'm going to fly at some point. And at that point, I will also need your assistance because I need both my hands to fly the drone. Okay. So someone, I'd appreciate if you could hold the mic. It's a great pleasure also for me to be here. Actually, I've been attending IMAV for quite a while. The first time was, I think, 10 years ago. It was, Guido who invited me to the conference, and at that point I was working as a PhD student in Brussels, developing robotic hummingbirds. So it's kind of related to the talk to the presentation I'm gonna be giving today. And I do remember that I actually did win the Best Paper Award. I don't know if it was that year or the year after. And I got like a little quadcopter drone. And well, yeah, we decided that maybe it would be nice to also bring some prize to the competition. So I will not say what it is, but there might be a nice prize for the winners of this competition. Okay. I'll be talking about Flapper Drones, which is a company we started with Rick Rousing 3 years ago. Yeah, like you're familiar with flying robots, of course, and you also know that most of the flying robots these days, they use rotating wings, propellers, rotors. But if we look at nature, well, we actually don't see any propellers, but we see wings, flapping wings. And so this is what made us curious, like can we build a robot that flies like that? That was back at the university, and as a company we actually, show that it can be done. And we're in particular interested in flyers that fly just by their wings, so they don't need a tail to stay in the air. So animals that can hover, so bees, hummingbirds. And yeah, of course, we didn't develop all the knowledge within the company. So as I said, I worked at the ULB and then at TU Delft, where there's been a lot of research into this domain. But this is where we started. We got quite a lot of publicity as well, and as a result of that, in 2019 we started Flapper Drones, a spin-off. We are based in Delft, but we're now in process of moving to the Czech Republic, where I come from, and that's where also our drones are being produced now. So it's not that we're the only producer of flapping wing drones or toys or robots. There are some as well, but most of them can only fly forward. They cannot stop and hover. And there are some examples of those that can do that feat, but then those are typically prototypes that are not for sale. And the reason is that they're quite complex to produce and to maintain such that they are operational. And what we came up with at TU Delft first, and then we made it more robust, is the Nimble Plus, a drone that actually is the first commercially available that can hover, that is quite agile, and it has a decent flight time that can still carry some additional payload. So you can see some videos here, but I think it's nicer to see it. So Guido, now is the time.
This is my important role, is basically microphone stand. So I will write, or do I need to throw or fly something?
No, exactly. That's your role now.
Thank you. So. I have a wire though, so for the microphone I'm kind of limited to this.
So you may have seen the Flapper already during the coffee breaks at the aula today, but for those who haven't, or for those who still like watching it, here goes the demo. So the drone can just take off vertically and hover like a quadcopter and do basically anything that a quadcopter can do. So it can fly forward, backward, and also sideways. I will later explain how this is done. It can of course also yaw, so rotate around this axis, and you can combine all these motions. So you can fly around really like a bird. But you can also do some movements you wouldn't really see in a bird, but are still kind of cool. Like this pirouette. I said that the drone is quite agile. So like it can go from standstill to fast forward flight and stop again. Well, even if it hits something like now, it keeps flying, and that's thanks to the fact that the wings are moving back and forth. So if you touch it, it will, like maybe get distracted a bit, but it will keep flying. So it's very safe compared to quadcopter, for example. Yeah, I think this is pretty much what I wanted to show you. If you would like to try it out yourself, tomorrow we'll be at the Tomato World, so you can pass by our stand and try it out. Let me try to land it now.
Wow.
Perfect.
Really fantastic, Mathieu. Thank you very much. Is there still something? Yeah.
So this was sort of an introduction, actually. No, but I got already a lot of questions from you during the coffee break. So here are the specs of the Nimble Plus. The weight is quite low for its size. So the size is 49 centimeters wingspan. The weight is only about 100 grams without any payload. If you add the shells and other things, it weighs a bit more. But you can carry up to 25 grams of payload, which can be some sensor or vision system. It uses brushless motors, rotary servo, and flies for at least 5 minutes. That is at hover with the payload, but in reality it's even a bit more. And if you need like long flight time and you don't care about how it looks, you can use all the payload capacity just for the battery. Then you can go over 15 minutes. Now, we're actually selling this, and most of our clients are from academia, so they use it for further research. But there are also companies that use it as a development platform. They sometimes try their own sensors, how they behave on such a different platform. And the reason why we actually started the company was we wanted to create shows with flying, like fairies or robotic birds. Flying in swarms, and that's still one of the directions where we'd like to push this. If you're interested in how this works, please come again to my stand tomorrow, and I'll explain. But what you need to do is you need to create the 3 torques around the roll, pitch, and yaw axis, and that is done by some small tricks, which I can show you. This video shows it, but in the interest of time, I'm going to skip it. As Barbara said, we're actually working a lot together with Bitcraze. We're using their flight control board, the Bolt, which is great because it has all the hardware we need, and at the same time it gives us access to the open source software and the ecosystem around their products. Not only some features are integrated, like logging of flight data, interface for RGB LEDs, or power management, but you can extend the functionality by adding add-on decks, which are originally designed for crazy flies, but most of them are also compatible with the flapper. Now this also means that if you want to develop something, if you're already developing something with the crazy flies and you'd like to try a flapper, it's very easy for you to port the developments to this new platform. Actually, the demo you may have seen this afternoon, where you saw 4 crazy flies and 1 flapper. Well, we just took a flapper and replaced 1 crazy fly with a flapper and ran the same code, and it just worked. The firmware is pretty much identical to what you run on a crazy fly. There are some minor differences, so currently it's a fork, but we're working on integrating everything to the same brain so that it's even easier for you to switch between different platforms. So as I said, it's a robot, it's not a toy, so you can actually also use it for research. It's compatible with various positioning systems like all the crazy flies. And yeah, if you get a flapper, you of course get a box with all the accessories. But what is important, I think, especially for research use, is that you can also get all the spare parts, because it's a flying toy or a flying robot. So eventually you're going to crash it, something might break, but we do supply all the spare parts as well. So it was designed to be modular, and you can repair everything, replace everything. So as I said, like most of our, let's say, clients are in research. This is actually a test from here, from TU Delft, by Sunny, who was Sunny Wang, who was, sorry, Diana actually, Olenik, but I'm sure Sunny was helping out a lot as well, who was testing the response of the flapper in, let's say, gusts, or in this case, it's just steady wind. But you can see it's flying autonomously within a motion tracking system, logging data. So it's just an example how you can use this platform. And yeah, you can also learn things like that the power consumption is actually 80% at about 3 meters per second compared to what it is at hover. So it's actually more efficient at forward flight. But some of our clients would also like to use it for shows. And this is an example of actually an opening show we gave at a technology festival in spring or in May here in the Netherlands. These are just 2 drones, but you can imagine how it would look like if you would have 10 or more. So on top of that, the appearance of the drone can of course be changed. Not only the shells, but you can actually also play around with the wing shape. The wing design we are using is optimized, but even if you change the shape quite a bit, like you can see on the barfly type of design, it still flies pretty well. So this is actually what we like to achieve eventually, concerts with robotic birds or maybe a fairy forest in a theme park. Now, finally, I'm always getting in question, why is this better than a drone, than a quadcopter? Well, I already demonstrated to you that it is both safer and more tolerant to collisions than a drone with rotating wings. And that's because the wings are moving back and forth. So whatever you hit, it's like at the point when the wing is still. And it is a soft wing, it's not a sharp rotating object. So yeah, you can see what happens if you fly into some gerbera flowers with a flapper drone and with a quadcopter. You don't leave any damage with a flapper drone. But other features are also important, and that's sound and how it's perceived by people. I often get this comment from people that actually it sounds nice or nicer. And we think this is important for future when we have a lot of flying robots around us. You want them to be, like friendly, and you don't want them to interfere with our way of living too much. So, like last thing, this is more about the direction where we'd like to go as a company. Right now, the flapper has this size, so about 50 centimeters. But of course, we would like to make it also smaller for some applications. And yeah, the smallest we could go with this technology is 25 centimeters, but eventually, as some universities have shown, you can go smaller once the technology for that is ready. And by that, I mean especially actuators and also power circuits. So that's a matter of time, but for now, this is what you can get from us. Okay, well, thanks a lot for your attention. Again, it's a great pleasure to be here, and I also look forward to the award ceremony on Friday. Yeah, there will be a little surprise.
Yeah, I'm really curious what the surprise will be on Friday. Yeah. Yeah, okay, let's not go there. There's like all kinds of strange ideas going through my head. But okay, thank you, Mathieu. I think it is indeed truly inspiring. So. I also like the proposal that people can actually fly it tomorrow. Okay, it's actually easier than a quad. So it's easier than a quad because a quad, if you fly it, then in order to hover after that, you need to basically pitch back if you're pitching. While the flapping wing just breaks by itself because of the drag of the wings. Anyway, so thank you, Mathieu. We're going to continue our program because actually each team has 2 slots. I also see that they were calibrating the motion tracking system, so perhaps they don't appreciate me saying that we're almost going to start again. So I'm going to look at the... Not yet. Shall we give them a small break? So they're just checking that the motion tracking system works because the distance, of course, we don't do that by eye, but we use the motion tracking system to determine the distances. And that is one of the most determining factors for a win. And we saw in the first session that the Pulp team did very well. So they look very confident for their second run as well. So let's see how that will work out. So we have mats in the arena. So you may be wondering why we have those mats. Normally people put such playing mats to give texture for the floor. And that is then nice if you have a down-looking camera doing optical flow, then these mats give extra texture. But here, actually, to be honest, the Crazy Fly just works anywhere. So it also works over the grass, which has enough texture to estimate the velocity. So we put these mats because there is a secret strategy that works very, very well. And that would beat all the teams here tonight. And we didn't say it to anyone, right, Christophe?
No, and you're not going to tell it now, right?
No, we'll tell it later, how you could have beaten all the other teams with a very, very simple strategy. And so we'll do that at the end of the evening. And it's to keep you here, right? Some people want to leave and eat, that's not allowed. So we stay here because we want to know the secret strategy. So yeah, so we'll tell you that later. So they have been testing the OptiTrack system. And we're now waiting from a sign from the... Sunyu, are you the head judge or you're the timekeeper? We're still at 5 minutes, right? Okay. Nee, ik had de mijne op. Nee, dat is niet voor mij doen. Maar als je er eentje mee kunt brengen, dat is een volle. So we have many PhD students and other staff helping out, and during the conference dinner, some of them will even be helping to serve us at the tables, and this is all because of staff shortages in all fields in the Netherlands. So I think it's really great, all the help we're getting from all the PhD students, and so yeah. It must be quite a tiring night for them, especially Tom, who is behind the OptiTrack system. He wrote a script to track this distance, but it's also quite intense. And well, Jeroen is no longer there for the streaming, so I guess he caved in. And so Christophe is now doing it. He won't be back. Oh, he will be back, okay. Oh, the drone is ready, actually. So are we ready to go? Thanks. Merci beaucoup. So the drone is ready. The team is ready. The judges are ready. And we have a takeoff. Okay, that was. It's actually a pity because earlier this evening they flew 5 minutes without hitting anything, and now there's a first obstacle is problematic. So perhaps they were trying new code to fly faster. And so let's see what they will do now. So tonight we have for the first time during IMAV a mobile streaming cameraman. It's Salil. So thank you, Salil. It looks a little bit like the Blair Witch project. I don't know what you were doing a second ago when you were not here. But the drone has taken off, and let's hope that they will make an impressive run as earlier tonight. So I think they put it much quicker now, so it seems to make more speed. And so they've scaled the gains. Wow, this is cool. They're really going for a record here. This is again, so this time the team didn't do a presentation, but if I remember well, no. Everything is on board, so they're using the GAP8 on board. This is actually the team that is involved in the development, so they're called Pulp. They're involved in the development of this processor, and this is in this case they have a tiny deepnet that takes the images and then maps it to control commands, trained in simulation, and it's really going fast. I mean, I think this is very impressive, guys. So. It was cool because earlier today they had a presentation where they could also recognize faces. So if they see a person, they could fly to it and perhaps interact with the person. So yeah, it shows that if you have these tiny nets, then you can make it do more and more complex tasks. And what we see now is that the jamming judge is moving some obstacles to make it difficult for this tiny drone. And ooh, it just braked on time, fantastic. And so for those who are perhaps not in robotics, it's very difficult if surfaces have a uniform color. And so the black object, although there's a lot of dirt on it, as everything in our Cyberzoo, it is quite uniform and it's actually hard to detect. And so it's quite impressive that it detected it. It does seem to be a little bit stuck in this corner. Ooh, and now this is going to be difficult, close to the screen there. It's looking at the screen, but it's also looking away. It's going to say, nah man, I'm not going that side. And so it does like Federico, I have the idea. Does it like you? You see that Federico is... You're not moving, right, Federico? You're confident, right? You trust them?
Part of the simulation.
So in simulation, they may have had some of these obstacles, but they definitely didn't have simulated Federico. And so it's quite cool that they also detect Federico. And I think Federico is trying to move the obstacles so that the drone can go to another part of the arena. And so the main task it's doing is to avoid obstacles. So it's not really trying to keep track of how much it's exploring. So let's hope it will get out of that corner again. It's very close to the screen, and it's gone again. Yeah, I think that's great. Ooh, what's going to happen here? It's just on time, stopping just on time. Just besides the screen, from my viewpoint, it looked as if it was going to crash. So Stijn, you work a lot with drones. Did you ever see this before?
A crazy fly avoiding obstacles?
Yeah?
Maybe.
But with vision?
No.
Okay, that's what I wanted to hear. No, never saw this before. It's true. It's really impressive what we see here tonight. And I invite the team to fly it tomorrow at the greenhouse. You see one of the team members really scared. I mean it. It would be great. But in the curtain. Sorry. So they're doing a quick reboot, and then we're going to start again.
Fortunately, there's no Linux, so you can just unpower and repower within only a few seconds. 1 minute left. And another takeoff. And a nice and steady hover. It would be even better if it would move. Trying to find a safe direction. Oh no, there's the black obstacle again. This is pretty annoying because the curtains are also black. So that makes it, first of all, hard to detect. Very little contrast between the black panel and the black background. Pretty hard on the computer vision. A lot of standard algorithms would fail with that. But it didn't hit the black wall yet, so that's a great achievement for the team. Ten seconds left. 5, 4, 3, 2, 1, and amazing performance. A
A big applause for this team who managed to squeeze all this computer vision into the tiny 4.4 gram gap processor board from Bitcraze. Very, very impressive. Like Guido said, I have not seen the Bitcraze avoid so many different new obstacles, because they're all new. The teams could not test here. They tested in simulation. And being able to avoid it almost out of the box is impressive. The next team is Madrid. The team from Madrid. Do you want to have a second attempt trying to beat your previous record? The team from Madrid, UPM. Yes, there they are. Great. Good spirit. Have another go. We wish you all the best. In the meantime, the jury is putting back the obstacles in a relatively standard startup setup to make it fair for all the teams, because the last team had moving dynamic obstacles, making it extra hard, but giving most points by having a very high multiplier. So the next team didn't want to comment on didn't want to anticipate on the performance of their drone. It remains a robot, so it has a bit of a will of its own. That's why we go testing. They're as excited to see what will happen as we are. What will the robotic code do? Next up is Skyred. So if you hear me, Skyred, you can already prepare mentally and come closer. Can I have somebody from Pulp? Don't walk away through the back. Don't sneakily go away. We want to know how it went. Yes, this way. I can see you. So guys, how did it go? Are you happy with the performance? We're impressed, but how did it go?
Very well, I gotta say, yeah. Like, we were not expecting to never crush the first run. The second one was also quite good. So.
It got stuck at some point a bit in the corner, annoying corner. It looked around trying to find a safe direction, but there appeared to be danger everywhere, so it stayed there.
Yes, he really likes to find sweet spots and just be there, like the comfort zone, you know.
It's like a local minimum in the potential field.
Not ideal, but you cannot get away.
We're glad that it, in the end, managed to escape this local minimum and still made a lot of meters afterwards. It was flying fast. Did you up the speed for the second attempt?
Yeah, of course. We were expecting like to see more crashes, but it was in the end quite good. Yeah.
You wanted more crashes, but the avoidance was too good.
Yeah, exactly. I cannot brake.
Well, thank you very much for participating in IMAV and for helping out developing this GAP 8 processor. And yeah, we'll see the results on Friday. Oh, too bad you won't be there. Then we'll send you the YouTube link. And is there nobody of the team that's left? So hopefully there's still somebody around just in case. Have a good night. How is CVAR? Almost ready. Perfect. Exactly what we wanted to hear. Our mobile camera is trying to squeeze in through all the people to get us some close-up shots. The laptops are opened. Terminals are scrolling text. See a lot of code on the screen. Still programming. The jury is ready. It's a totally different approach, streaming the images to the computer, which allows you to run much heavier computer vision, but it's in a way much more difficult because you have delays, you have dropped frames, but maybe with a little bit less people around, the Wi-Fi is better. The drone is on the beautiful cardboard takeoff platform. And we have the good red blinks. There's also a bad red light, but this is the good red light. Close-up view from our mobile cameraman, showing all the secrets of how to press the buttons for a quick startup. The self-test showed that all 4 propellers are still spinning. Be careful when you boot it in your hand. The camera filter doesn't like motion when booting. Creating in-air bootable camera filters is an extra challenge, but we don't give extra points for it.
Okay, so we're trying to boot the drone, keeping it closer to the ground station. Oh yeah, that's also mine. Okay, I'm collecting them. But sometimes we make them take off from these cardboards. It's a little bit more reliable than from the grass here. So the grass may go, may make the drone go a little bit obliquely. And I don't know if anybody walked inside. Did you guys walk inside? Yeah? Did you have shocks, like electric shocks?
Sometimes. Yeah, a little bit.
It's nice, huh?
Wakes you up within sleeping somewhat little.
It's nice, yeah. So people here hate the guy that invented the idea of the artificial grass because you walk and then it gets static and then you touch something and then you get a shock. So some days it's really bad. So they always say, string up that guy that thought of the artificial grass, right, Sven? yeah, he says. I never said that. You thought it. I thought it. Yeah, I wouldn't have said it. Yeah, anyway, yeah. Yeah, let's not disclose who came up with this idea. But yeah, sorry. But so yeah, so in the meantime, I mean, this must be a stressful night for the Madrid team. Uploading code. I'm now guessing, I don't know. If I get more information, I can tell you. So Nick, this is your first IMAV. What do you think until now?
It's really cool. I've enjoyed it. A lot of interesting talks, especially a huge variety of topics. That's what I enjoyed most.
Cool, yeah, that's exactly what it's about. And when you look today, because you've worked a lot with small drones, but more racing drones, right?
Yes, during my master I've worked with the smallest drones around here, so yeah. But I think we've seen those most today here. So.
Yeah, these are even smaller. But yeah, it's quite impressive, I think, what many teams have shown, what they can do. And so what do you think? Yeah, we should ask at the end what you liked. But it's already nice you say variety of topics, because that's really what IMAV's about. So yeah.
Yeah, especially like the sessions, they have 4 or 5 presentations, but this really huge variety, a lot of different topics still within one session. That's what I liked most so far.
Cool. It's only going to get better, so right, Sven? Tomorrow you're streaming in the greenhouse. Looking forward to it?
Yeah, well, I'll be sitting behind the desk while other people put on spacesuits to walk through the greenhouse. So I'm happy that I don't have to do that. So.
Oh yeah, that's true. Yeah. So tomorrow in the greenhouse, yeah, most of us will be public. So yeah, we don't have to do anything strange. But when you go into the greenhouse, you need to put on a whole suit and get disinfected. So, and that's really fun because it's like really warm there and you have this extra suit. So it's even worse for the teams, basically. We shouldn't say that, right? But yeah. And the drone is taking off. Oh. Sven is saying that one propeller was not really turning, but yeah, did it hit the grass? So Sanyu, how many minutes do you have on your clock? Still 5, or still 5? Okay, good. That's the positive news here. It's also your first IMAV, right, Salwa? What do you think until now?
No, yeah, it looks great. Yeah, I mean, I think it's very exciting that it's one of the few conferences where you have a lot of competitions. So, and yeah, I think it pushes really the boundaries of research and development for new prototypes. So, yeah, looks.
Very nice, very nice. What a good answer. Yeah, you knew, of course, that we were streaming this, but so I'll ask you again later what you really think. And so, but thank you. It is a perfectly diplomatic answer. Okay. Okay, so they swapped the antenna, reattached the propellers. It's a typical checklist, right, for the Crazy Fly? No? Oh, you shouldn't say that. So if in the meantime the Skyrats could get ready. Yeah, very good. So it may be that if it doesn't succeed, then we give them some extra time and we put them at the end of the schedule. And then if you're ready to go, yeah, then yeah. Okay, so we'll still take it easy, and then in 30 seconds, no, we'll see you when. So we'll call you in a little bit. Oh, we have a takeoff. So, I guess the time has started as well. And there they go. Wow, through the gate, come on, that's an applause, yeah.
That's a full diagonal plus a gate.
Yeah, it's a gate plus a full stretch. They did find the beach flag. No extra points for that, but yeah. So there's only a few teams that do these gates, and now what is going to be very interesting is because Skyrats, you also go through gates, right? So yeah, so it's very good.
So they say.
So it's going to be very interesting how that works out in the score. So yeah, tonight we cannot give you the results because there's a whole team of people that's going to analyze in depth all the data, you know, for days. So 2-3 days, full team working on that. Yeah, we don't have a script to count the distance at all. Right, so. There was a little crash, so I don't know if the time keeps running or not. I'm looking at Sanyu, it's running now, yeah. 4 minutes remaining. And normally I get really annoying. I say like 3 minutes 59, 3 minutes 50, but let's not do that today, right? That would be not so nice. So we're going to have another takeoff on the other side of the arena. And it would be very cool if it also goes through the gate again. Go drone, go drone, go drone. Aligning. Detecting. And go! Through the gate, through the gate. Yes, through the gate! Yeah, so there was Dutch television here tonight, and they were asking when will this become a product that is all around us. So I said, well, in a month or two or something, because yeah, no. It's fully autonomous flight. It's closer by than you think. Yeah. So Vede, can you? So let's have a little chat with our referee while the team is debugging. So what do you think of tonight? Did you see some big fouls or not too much?
I mean, it was a great performance. Like all the teams put a lot of effort in this, and yeah, I mean, they spent a lot of time preparing for this day and for the competition. It was lovely, like working with them and organizing the event together with Tom and the other colleagues. So yeah, congratulations to everybody.
Yeah. So thanks from our side to you and Tom, because you've been working day and night to support the teams. So thank you very much. But you still saw nobody cheating yet.
Nobody cheating. I actually was a little bit afraid that someone was going to cheat or try to exploit, because that's always like what people like doing, right? But no, everybody was fair, playing nicely, so yeah, no problem.
Ah, fantastic. Yeah, good to hear.
No red card to
No red cards, okay. So we have, they're switching it off. Yeah, so this is a little bit the crazy fly competition equivalent of the pit stop in Formula One. So because the time is running, you see that the team is really frantic. They're frantically changing batteries, switching on and off, uploading firmware, debugging the code. Sanyu, can you whisper the time? Oh yeah, changing batteries paused, right? 1 minute 45, so they can still do some meters. So Pasquale, we have to cheer on the team, right? So because 1 minute 45, everything is still possible. Yeah. So there they go. We have another takeoff. It's going through the gate very nicely and into the net. So it sees all these gates in the net, of course, that it wants to pass through as well. I'm actually surprised that it doesn't fly through the net, because it's so small, right? So it will fit, right? Did you ever have it? Yeah? Where did it go? Almost killed me. Oh, really? You see the scar? I thought it was from a bar fight, but it's from a crazy fly. Okay. Okay, there they go again. They're passing through lots of gates tonight. Perhaps we can put some obstacles in between. And now it's actually flying and avoiding obstacles. Very good. And landing. Yeah, it's pretty good. It has the attention span of my children though, so like 3 seconds. Okay, my children hopefully are not watching the live stream. Don't learn English. Seven, 6, 5, 4, 3, 2, 1, 0. So we did see 4 gate pass-throughs and keep a Skyrat. Yeah, so that's putting a bar high. Yeah, so very nice. Okay, yeah. Please, I would say get installed. So, are there some Skyrats here in the audience? Yes. Very good. Hey, so why are you called Skyrat?
I'm sorry?
Why are you called Team Skyrat?
Oh, because we are from the Polytechnic School of University of São Paulo, and our mascot is a rat, so we fly drones, and then we are Sky Rats. We have another team called Thunder Rats, for example, and they do robots that fight, so we are kind of inspired by that.
Oh, very cool, very cool. I thought because, so where I'm from we have lots of pigeons, and it's more like a plague, and we call them flying rats, so I thought...
Yeah, we like this joke also. Yeah, a rat that flies is a pigeon, I agree.
It's a pigeon, yeah. Okay, sorry to all the pigeons out there watching the live stream, but yeah, it's you're right. And are you joining any competition yourself? Like?
Yes, I'm taking part into the outdoor mission, and on Thursday, I guess. So that's why I'm watching right now. Another part of the team is testing the drones for the outdoor, but I chose to stay to support. And then tomorrow I'm crazy testing for the outdoor mission.
Ah, very cool. Did the testing go well on Monday, or still some work to do?
There is some work, but we're hopeful. I'm very hopeful.
Okay, very cool. Okay, I'm looking forward to that. So the team seems quite ready. The takeoff location seems quite dangerous there, in between all kinds of obstacles. So Stavro, since I see you here anyway, so is that a real beer?
Yes, it is.
Okay, yeah, so I was wondering, because you also did the challenge we do with the course, right, in the studies?
I did indeed the obstacle avoidance challenge, yeah.
Yeah, so to those who don't know, so we actually give a course to master students, and within 7 weeks they learn how to program drones and then fly them, and they do actually the same kind of competition with monocular vision, but then with a Parrot Bebop. Now, of course, you know, Parrot Bebop, they don't sell them anymore, so we need to change. Perhaps, you know, we will use crazy flies in the future. Is that an idea, Bitgrace? Yeah, then you get even much more orders from our side. So, but we may actually consider that. It's actually a cool idea. Yeah. So yeah, thank you, Stavro.
Actually, that course that made me like make the decision like to go like continue with working with drones. I did an internship after that. After that, I wanted to do my thesis, and now I'm doing my PhD here. So
yeah, it's cool. Yeah.
It's all because of that course. Before, I was not even interested in drones. So.
Oh, that's cool to hear. Yeah. Because I was just gonna ask, like, is the competition better with beer?
Yeah, to watch for sure, but like I wouldn't really participate. If I would participate, it will probably like just bump in everything. It will be like an orange attractor, like it just go to everything that's orange.
Okay, yeah, that's very cool to hear that you chose all of this because you did that competition. So yeah, nice. Duty.
No, we put the label that it's not for children.
Hey, we have a takeoff. Oh, I missed the crash, so we were just talking over the competition. Who cares? That is this drone doing it, flying around. So yeah, and it's stopping here at the edge of the arena. I think that's pretty magical, actually. How does that work? We should ask the team once. Oh, it doesn't. It works on the blue side, but the black side is difficult. You see that they run into the arena to quickly retrieve the drone. I only hear you talking about me. Tell me. We're just tracking the amount of beers you've consumed over the night. Okay, it's all 0% tonight. Yeah, you really don't want to see me if this was. Yeah, that's I don't. Yeah, the bad jokes you mean? Yeah.
Maybe this turns into karaoke.
Hey, you don't want to go there, Federico. I have some memories of you, huh? Yeah. So the drone has done a takeoff again. Yeah, let's not go into all kinds of stories. It's looking at us. It's nice. Okay, turning. Go Skyrats. It's actually also faster, eh? It's pretty cool. Come on, stop on time, stop on time, stop on time. So this is the Yolo mode, so they put it in Yolo mode, and so to go even quicker. And yeah, it might just work, of course. If somebody should take the mic, yeah. I don't know where Christophe is, he abandoned me. Perhaps he's eating, you should not do that at a night like this. I mean, food, no. Yeah, that's true, yeah. So you think? I think it crashed because it was not oscillating. What do you think?
It's possible.
Yeah, it should have been oscillating, but yeah, nobody told the teams up front, so yeah. So it's turning around. I'm pretty sure if it finds the direction, it's going to speed. It's making a victory round, I think. Oh no, that was not the way to go. So that's one of the good things about crazy flies. You just take them by the leg and you put them upside down, and then they stop spinning. So you can actually, yeah, you don't hurt your hands. It's good, right? Do you also put that on your big drones if you have them? Or?
I would. I have not done it yet.
It's a good idea, right? yeah. So I'm wondering how much time we still have, Sonny. 30. And it's paused, right, at the moment? Or is it war? Oh, it's going. Oh, 24 then. Come on, guys. One last takeoff. Seconds I hear. 5, 4, 3, 2, 1. Okay, but hey, great run anyway, so please give him an applause. You really took it out of the sky, that's pretty cool, huh? It's nice, yeah. You can recognize the crazy fly experts. You just take it. Yeah. Very nice. The black bees, yeah. Where are the black bees? Black bees? Christophe, the black bees, are they with you? Ah, they need to go downstairs. Stop shooting. Okay, they're coming. Very good. Yeah, we need a Brazilian cheer for the black bees.
Vai Brasil!
It's pretty cool. Yeah, do you want to take the microphone? Do you? Yeah, that's true. When you become a dad, you make more and more dad jokes. It's just...
I just said I would probably be a good dad at some point.
Yeah. And the more it annoys your children, the funnier you think it is. Yeah. Yeah, I don't know. That's not good, right? To admit on YouTube. But who's watching? How many watchers do we have? Can you see it? 46,000. Wow, that's amazing.
We have 570.
Oh, I'm connecting all the zeros and stuff. So it's like 50 at the moment. Yeah. Oh, that's good. Yeah, so yeah. Still there, 50 people. I guess they just switch it on and then they just go and drink coffee or, watch TV next to it.
You drink a beer?
Oh, they're here for the jokes.
They think this is stand-up comedy.
Yeah, it's actually also increasing, eh? So look, there were 46, now 50. And if we continue like this, I mean, yeah. Yeah. Oh, I don't know. But I do have corona, so no. Oh, it's Heineken. Oh, yeah, that's it.
Maybe if Christophe and you do like a duet or something.
Oh, yeah, we should try. Yeah. Yeah, I mean, and the worst thing is, the worst thing for the audience is that this is today, and it's only a few hours, but there's also tomorrow, and there's still also Thursday. So, yeah. So what you can do is you just earplugs.
I wouldn't say that's a bad thing. It's definitely good for the amusement.
Okay, yeah. But earplugs, that's the thing you need for the other days.
So actually, to interview you, have you ever considered a career as a stand-up comedian as well?
No. I don't want to, do that to people. No comments. Yeah, anyway. Okay, the team is already flying for 5 minutes. There's like 10 gates.
weren't we recruiting a new commentator tomorrow?
Oh yeah, if there are volunteers, like we're still looking for commentators tomorrow during the Greenhouse Challenge. That means that you want to do it, right? Like the little owl. Oh, yeah. So, we have Tom actually repairing the Crazy Fly, so that's pretty cool. Less. We accept Spanish, it's not a problem. So the team is working hard to fix the Crazy Fly. So at the end of the evening, you can go to the BitCraze people and tell them all that you experienced during tonight. So it's a lot of suggestions for.
Looks like he's ready for the second round.
Ah, yeah. But weren't you last in line? Yeah. Oh, are we almost there?
I think he has a face that he wants to speak.
Oh.
This is not there. The simulation.
Oh, yeah, the next step. Oh, so this is the penultimate team. It's a difficult word. It's the one before the last. I'm not looking at you for any reason. You knew what it meant, right? Penultimate, yeah. Okay, and the drone is entering the arena. Oh yeah, we have 37 viewers now. Who made a bad joke? We should punish them. Okay. You can do it as well. Can you say it, please, louder? Oh, come on, Krista. This wire is long enough to reach.
No, you do it. You do it. No, you do it. You.
Try it. You can do it.
We believe in you.
Oh, this is interesting. They still need to plug in propellers. So putting propellers is really helpful for the flight behavior. The clockwise spinning propellers are on the diagonal, left diagonal.
You're looking for fun facts. So some technical information. The Crazy Fly has 4 propellers. Yes, they spin. You have one pair spins one way and the other pair the other way. Yeah, so they do that on purpose, Aniek, on purpose. Yeah. Yeah. So it's to counteract the moment. Yeah. It's. Oh yeah, damn. Yeah. Okay. Yeah, you can do that. Yeah. And they're ready to take off again.
Takeoff.
And a takeoff. It's flying up and down. That's interesting, because the camera must be pointing one way and not the other.
This was a static environment, right?
They fly a long distance like this. Up and down.
So if you remember the presentation from this team, they said they ran into some issues with the computer vision, so they opted for a strategy to just maximize points. And it appears that they have found a strategy asking for static obstacles, not by accident. Tick, tock, tick, tock, ping, pong. Jury, do we have?
We have 34 viewers.
I would like to have the head of jury nearby. What is the rule for ping-ponging teams?
We should intervene and put an obstacle in there, but I think they took the camera out.
The camera actually is completely removed, so you have longer flight times, which is clever thinking. Yeah, no camera, longer battery lives, no battery swaps, and just ping, pong, ping. So it's actually a very interesting test, because now the drone is flying on integrated VIO from the bottom camera. And apparently, it looks like there might be a little bit of drift after all. So I'm still impressed by the quality of BitCraze's bottom-looking camera. It's not perfect, but as long as they had a lot of texture, initially it was over the mat. Then you saw little drift. Once it started going over the green grass, the texture removes and the integrated drift increases and increases until in the end the curtain came too close.
Yes. Sonyu, how much time do we have left? 2 minutes 55 seconds. And there it's going again. This is what
would you have put it on the carpet with a lot of texture if it were you? Yeah.
Ooh, pull the carpet. Oh, we don't want to do that, right? So yeah, it's flying up and down. Yeah, thank you for filming this, Federico. We're very happy with that, right, Chris? Absolutely not. One of our shining moments. Commenting, especially this one. It's nice. They already took the flag out for the award ceremony, right, guys? Ping, pong.
You reduce the amplitude of the ping pong, so that's not beneficial for the total travel distance.
And it's slowly drifting into the curtain. I have the idea, but of course we can see it better on the images by Fede, who's inspecting it up close. I would like an update on the time. One minute 35 seconds. Time flies if you're having fun.
But this team did some clever thinking about how to use the rules for the maximum benefit. Typically, it's us that do that, right?
Yeah, I just was going to say, are we not guilty of that? I remember a few entries into IMAV that played the rules a bit, Christoph.
Yeah, I always say lead by example.
Exactly. So, yeah, nice. Thank you, Federico. Are you going to follow us around also during the toilet breaks? Yeah. Hey, the stream's going up. So for those who napped off a little bit, the drone is going one way and then the other way. And then one way and then the other way. And how much time do we have left? 40? Or 30? Okay. 30? 20? 10? 13, okay. Come on, get those extra meters in. Keep Black Bee. 2, 1, 0. Well, let's give them applause because they had a lot of. They had a lot of problems they needed to overcome. So, of course, sorry for the jokes. Don't watch the stream back. So, yes, and then we're on to the last team, right? So, where is the last team? We call it the Magic Team, right? Or what is your name again?
It's Crazy File Folder.
How did you get to that name?
Just some random thought on it.
Okay, very good. Okay, yeah, that's promising. So yeah, please install yourself and. So Ingfu is actually one of our experts on deep neural nets for high-speed flight. So I cannot see this going wrong. And Chang is also a PhD student here. They've been working. We advised them not to participate, but they were really motivated. So then we said, yeah, why not? And they have off-board processing. They're using depth maps, right, Sven? Did you follow that talk before?
No, I didn't. I was so busy with the streaming that was my task for the day, and I think we did great. I think we did great. There was a few little hiccups, but we did our best to resolve them. Yeah, and if people don't show up for the remote presentations or drop out, then there's little that we can do.
Yeah. Okay, completely agree. And we have the last run tonight, and then I'm sorry to say, then you really have to go home or get dinner or do other stuff, other useful stuff. Yeah, but let's save our energy for this last run. So for those people that have television in their hotel or house, Stavro,
I don't have a television.
You don't have a television. Okay. Who has a television? Yeah, I still have a television. Yeah, with television screen. I mean, yeah. You can. It's also streamed. So for those who have a television in their hotel room, so tonight there was a Dutch TV, and they came here and they actually filmed this competition. And so tomorrow it's like national news. What happened here today? Can you imagine that? It's pretty crazy. So I'm mostly wondering when they come by, like what do they show on the TV show, right? The drones crashing or flying around? Let's see. We can tell you tomorrow what they will actually cover. So it's for Atlas. So it's this is a little bit of commercial, but I think it's allowed on YouTube. So it's MPO2 Atlas tomorrow evening. So it's after the greenhouse jumps. Oh, they're already flying for half an hour. And are they going to fly? Did you land it yourself or automatically? Ah. Yeah, don't stand in front of the pole. No. There was almost a gate fly through. Was that planned? Oh, I shouldn't interview them while they're running around, right? So. Oh, the bottom is not the gate. Oh, that doesn't count. Only the orange part. Oh, okay, yeah. You have to be strict. Okay, there they go again. Traveling straight forward, right? More or less straight. Yeah. Ooh, wow, they really want to pick up speed. It's pretty cool. Stop on time, please. Go around the pole. So we were talking about this yesterday, that obstacle detection, you know, if you have like a classifier in computer vision and it does like 99% right, you're pretty happy. But on a drone, if you have like 1,000 images and you miss, I don't know, 10 of them, then misjudge 10 of them, then it can actually mean a crash. Oh, it's landing again because it detected the end of the arena. It is flying fast, that is very nice to see. So let's try this again. So in this case, it's off-board processing, and as we said before, off-board processing has its advantages, like you have more computation, but also disadvantages, which means like delay and interference of other Wi-Fi equipment. This is a pretty good run. I really don't see what's happening there. It's so small, these drones. Couldn't they make them bigger? And then you see them easier during the competition. It's a little bit why people don't watch field hockey. Who watches field hockey? Oh yeah, sorry, I forgot about that. Yeah, sorry. I should not make fun of field hockey, but... They do make the field blue nowadays. Oh, the field is blue, so it helps to see it. Yeah, it's a very small ball in field hockey, for the non-field hockeyers among us. And so with football, the ball is actually pretty big, so you can actually see it when you watch television. And with field hockey, you're just wondering, why are they cheering? Yeah. About field hockey. Now come the facts about field hockey. It's one of the main sports in the Netherlands. My son actually plays field hockey now. Klein Zwitserland. Is that a competitor for you?
They're a bit higher up.
Okay, a bit higher up. No, not my son, I can tell you. But they do their best. Okay, I really should not give this stream to my children. Yeah. Next Saturday not. We have an out match. Yeah. Tell me when you're there once. Yeah. Sundays. Yeah. Okay, but I'll come and watch nonetheless once. Yeah, it's nice. Sorry, this is like a private conversation. But I mean, if the drone was flying, it wouldn't be necessary, right? So. Okay, there we go again. So it's evading the gate. It's pretty good. Oh, the flag! It's such a murderous object. Who put that flag in there? Fede, you? Oh yeah, you're not guilty of that. Another terrible thing about flags is that so with the small drones is actually a pretty fair object, because they have very little. Whoa. That was pretty cool. Low pass through the gate. Yeah, we'll give you another point for that. No, we don't. We keep fair. But with the flags, if you have a big drone, then it actually the aerodynamics around the drone sucks it in. So we see in our competition with the course, we have bigger drones, and then the flag is really a murderous obstacle. But with the little drones, they actually don't influence the flag that much. How many minutes do we have left? Seconds? 45 seconds. Okay, exciting. There we go. And it avoids another obstacle. Oh, some people have worse obstacle avoidance than this drone. And it lands again. 10 seconds left. 9, go for it. 8, 7, go for it. 5, oh sorry, 3, 2, 1. Oh, 0. Okay, give them an applause, people. Okay, so yeah, for those who stayed, thank you so much. Yeah, it's really nice. Also, you also supporting the other teams until the very end. So thank you very much. Thanks again to BitGrace. I think it was a huge success, to be honest. And the course with the Crazy Fly and the AI deck, I think it's fantastic. Yeah, we should do that. So we'll talk about that when we're not on the live stream with millions of viewers, by the way. So also online, we still have a huge amount of viewers, 26. So I'm wondering what happens if we just stop talking, and probably it just stays through the night. But okay, so don't forget, tomorrow morning, it's really early, 8 o'clock at the Aula, so where we were earlier today. And then we all go to this greenhouse. It's also a pretty cool environment. So yeah, and then that's it for tonight. Thank you and bye-bye.